Alright guys, so we're going to go ahead and finish the unit, the last half of 9.5, which is about composition of trig functions and their inverses. So you've already seen a long time ago that a function and its inverse typically cancel each other out and undoes everything, and you just get the original input again. Same idea here. Here we have a function, but we're applying the inverse to it, and inputs should remain the same. It's kind of like if you have, for instance, the square root of x. Okay, so let's say that's your f. We know that the inverse of that would be to square it, because that's how you undo a square root. And if you notice, you just get x back again. And I think you guys remember from, I think it was chapter 3, that compositions like this usually undid, for instance, the original function and the inverse cancel out, and the inverse and the original cancel out. But that only happens, and this is the key, as long as x is in the domain of the inverse or vice versa. So in other words, and we'll do an example later on, if this 3 doesn't make any sense for this inner function, this does not work the way it should. If this 10 is not part of the domain of the inside function here, you can't just undo it and get 10 as your answer. Okay? So that's why it's very important that you remember the domain and ranges for sine, inverse cosine, inverse tangent, and all their restricted functions. Okay, so just to review, in case you don't remember, let's say restricted sine is our f of x. We know that the domain there from last time we did notes is from negative pi over 2 to pi over 2. The range was from 0 to 1. And for the inverse of sine, the domain and range just flip-flop. Okay? So then this is how these compositions work. Okay? First thing you do is check the domain of inside function. Okay, so for instance, this is the inner function right here. We have the inverse sine of 1/2. Okay, so first and foremost, we look for the domain of the inverse sine graph. The domain is from 0 to 1. And we notice that 1/2 is in the domain, because it's between 0 and 1. Whenever that happens, whenever this number is in the domain of the inner function, as long as we're doing the opposite function on the outside, these will cancel out just like we want them to, and the answer is easy. We just get 1/2. Okay? Let's do another one. So here we have another composition, sine and inverse sine. We hope that it just cancels out and we get 1/4. We have to double check again to make sure that 1/4 is part of the domain of this inside function, which is the inverse sine again. So the question is 1/4 between 0 and 1? Answer is yes. So because this is in the domain and we're doing a composition of inverse function with original function, everything cancels the way we want it to, and our answer is 1/4. Okay? Let's go down to E. Do a couple here. Okay, and for these kinds of problems with compositions, if you don't see the arc or the inverse sine, so here we just have sine, we're always referring to the restricted sine graph. the restricted sine function, where the domain is negative pi over 2 to pi over 2. Okay, so for part E, we have restricted sine. Our input is pi over 3. We just want to double check, is pi over 3 between negative pi over 2 and pi over 2? Of course it is. So the sine and the inverse will cancel, and you just get pi over 3. Okay, let's do F. On the inside is sine, so we're going to think restricted sine. Again, the restricted domain is from negative pi over 2 to pi over 2. Is pi over 8 between these two values? It certainly is. So again, these undo each other, you get pi over 8. So everything's worked out the way we wanted it to so far. Okay, so now we'll see a couple of examples where we have to kind of think about it a little bit more carefully. Let's look at G. So here, on the inside, we have the inverse sine. The domain for inverse sine is from 0 to 1. So if we're going to do our nice little technique where we cancel everything, we want to check the domain. Is 2 between 0 and 1? Answer is no. Okay, so then what we try to do is answer the question, is this even possible? Well, if you remember, when you're doing the inverse sine of something, it's asking you to find an angle. So you can think of this as taking the sine of some angle, specifically an angle where the sine is 2. Well, this case doesn't make sense because the sine is always between negative 1 and 1. Okay, so we can't even do this problem. This one's undefined. We can't cancel anything. We can't even get started with this one because it's impossible to find an angle theta where the sine of 2, or where the sine is 2. Okay? Let's look at this. Actually, let's look at I. This will be a good one. Okay, so here we have restricted sine again on the inside. And the domain was from negative pi over 2 to pi over 2. And now the question is 7 pi over 4 between these two numbers? Okay? And we see that that's not true. This is way too big. So just like before, we try to figure this out if possible first. So now, is this possible? Can we actually find the sine of 7 pi over 4? Okay, and the answer is yeah. That's just unit circle, so that's no big deal. So we have arcsine, and then the sine of 7 pi over 4, that's in the fourth quadrant. So that's going to be negative root 2 over 2. But now to find our final answer, we have one more step to do. We need to find an angle, because we're doing the inverse. We need to find the arcsine of negative root 2 over 2. Well, it's nice because these are our possibilities. We can only pick between negative pi over 2, so we can only go this way or this way and stay in quadrants 1 and 4. Okay? And we know that the sine is negative down here, and the fastest way to get to a y-coordinate of negative root 2 over 2 will be to go backwards pi over 4. Okay, so this is one of the ones that's a little bit more challenging, but it is possible. Okay? Sine of 7 pi over 4 does not cancel with arcsine to give you 7 pi over 4 because this angle is not in the domain of the restricted sine. So we go ahead and try to figure this out. Sine of 7 pi over 4 gave us this value here, negative root 2 over 2. And now we treat this as just a regular find an angle where the sine is negative root 2 over 2, working with, again, the domain for the angle between negative pi over 2 to pi over 2. Okay, let's go on to the next page. And now that we've kind of understand how this works, we'll cruise through some examples here. So restricted cosine, if you forgot, domain is from 0 to pi, range is from -1 to 1, so naturally the domain for the inverse and range just are reverse of the restricted cosine. Okay, so we'll treat things the same way as on the other page. On the inside, for this example, we have inverse cosine. To see if things cancel out nicely, we ask if 1/2 is between, let's see, inverse domain is right here, -1 to 1. It certainly is, so these will work out just the way we expect them to. Let's just go down this column. Another inverse on the inside. Inverse, here's the domain. -0.6, good to go. That certainly is in the domain. Here we have restricted cosine. Pi over 4 lives between 0 and pi, so we're good. So these will cancel out and we get pi over 4. Arc cosine, -3. The domain is from -1 to 1. Impossible. Okay? This one is not possible. It's undefined. And we can try like the other one. If you want to double check, since we don't have this number in the domain, then we just figure out, is there an angle where the cosine is -3? And that's what we're talking about here. The answer is no, so can't do it. Okay, let's do this last one here. This is restricted cosine, 11 pi over 4, though that's way too big. It's not between 0 and pi. So let's see if we can figure this out. The cosine of 11 pi over 4, let's see, 11 pi over 4 is going to be in quadrant 2. So then the x-coordinate in quadrant 2 is going to be -√2 over 2. Now, our last step, remember that whenever we have all we have left is the inverse of a trig value, we're looking for an angle where the cosine is -√2 over 2, and it's got to be between 0 and pi. So our only options are quadrant 1 or quadrant 2. Cosine is negative in the second quadrant, so the answer is going to be 3 pi over 4. Okay? Let's do the tangent page. So just scroll down, Just go to the bottom half of the page. Do the same thing. The restricted tangent function, similar domain to the restricted sine, but since we have asymptotes at -pi over 2 and pi over 2, we don't include them. The range, since it was like a cubic graph, is from -infinity to infinity. And then these just flip. Okay, so we'll cruise through a few problems here. On the inside, we have inverse tangent. Domain for inverse tangent is all real numbers. So this is good news. Anytime we have an inverse tangent on the inside and we're trying to undo that with tangent, the nice trick where they cancel will always work because the domain is all real numbers. So this answer is going to be 4. This is going to be 3/4. Let's see. Here's another inverse with tangent, so this is good. Okay, so those are good to go. Let's go back and finish the other ones. So now here we have restricted tangent on the inside. Pi over 4 is between -pi over 2 over 2, or -pi over 2 to pi over 2, so this is good. Tangent and inverse tangent will cancel. Same here. Let's see, here, 3 pi over 2 is too big, so let's just see if we can figure it out. The tangent of 3 pi over 2 See, the coordinates down here are 0, -1. So the tangent is y over x. We can't even do that. So this is undefined. Now, if this actually had a tangent value, then we can kind of keep going, but we can't in this case. Okay, so the last part of this section is these random compositions where we have arc cosine and we're getting excited saying, oh, this is easy, it'll just cancel out. But sine and arc cosine are not opposites of each other, they're not inverses. So for this we have to actually slow down a little bit, maybe even draw a triangle if we have to. Okay, so let's see if we can figure this out. First of all, inverse cosine, the domain is from -1 to 1, so we can figure this out. What angle has a cosine of -1/2? Well, if we're looking for an angle for cosine, we're always from 0 to pi. Cosine is negative, so then the angle would have to be, let's stay in radians, so 2 pi over 3. So this part right here turns into an angle, which is 2 pi over 3, and now we just take the sine of 2 pi over 3. So that's just root 3 over 2. Here's another quick, easy one. And by the way, this should be an inverse right here, tangent inverse of -1. So if we're doing tangent, the domain, anything will work with inverse tangent, and now the angles specifically have to be from -pi over 2 to pi over 2, so only first or fourth quadrants. If the tangent's -1, that means quadrant 4, and we know that's going to be an angle of -pi over 4. Okay, so the inverse tangent of -1 turns into an angle of -pi over 4. And now our last step is to do the sine. Well, the y-coordinate here is going to be -√2 over 2. So these are not too bad. You just have to be careful not to cancel stuff out. Okay? Let's do one where maybe it's not quite as easy. Let's do this last one, number 6. So 4/5 is definitely between -1 to 1, so that means that this is going to be possible, but it's not going to cancel because tangent and inverse sine are not opposites. And 4/5 is not something on the unit circle that we know. So, draw a triangle. We know that this part here, this inverse of 4/5 has to translate to some angle where the sine is 4/5. So you label a triangle, and you can quickly see that it's the 3, 4, 5 right triangle. Okay? And since this is inverse sine, we're talking about angles specifically in the first or fourth quadrants. Sine is positive, so we know we're looking in the first quadrant. If I do the tangent of this angle in the first quadrant, everything is good to go. And now we just use this reference triangle. The tangent of theta is just opposite over adjacent, so 4/3. Okay? So there are the notes for the last half of 9.5. Now we are done with the unit. Tomorrow we'll do some practice and some other stuff. Farewell.